So to determine whether the glycolysis reaction goes to a steady state or has self-sustained oscillations, we have to understand the behavior of the reaction near the fixed point itself. So let's look locally near the fixed point of this reaction. So we need to look at the stability of the Jacobian matrix about the fixed point. So the Jacobian matrix is the matrix of derivatives, and we can almost read it off because the equations of motion are so simple. So we take dx dot with respect to x, we get minus 1 plus 2xy. dx dot with respect to y gives us a plus x squared. And similarly, for the second line, we take derivative dy dot with respect to x, we get minus 2xy, and then we have minus a plus x squared. And at the fixed point, we get minus 1 plus 2b squared over a plus b squared, a plus b squared, minus 2b squared over a plus b squared, minus a plus b squared. Now from this matrix we can find the eigenvalues lambda plus minus, which are equal to 1/2 the trace of the matrix plus or minus the square root of trace squared minus 4d. It's a little bit messy algebraically to write this out, but what we can do is we can infer the behavior by looking graphically at the behavior of these eigenvalues, and here's a summary of what happens. So the true control parameters are a and b, so I'm plotting as a function of a and b the stability of the fixed point. And it turns out there's two regimes of behavior. There is a bubble that looks something like this, where inside the bubble one has an unstable spiral locally near the fixed point. And outside this bubble one has a stable spiral. Inside the bubble the trace of the matrix is positive, which means that if I'm close to the fixed point I will spiral away from it, whereas if I'm outside the bubble, no matter where I start inside the trapping region, I'll end up at the fixed point. But by the Poincaré-Bendixson theorem, we know that even though there's an unstable spiral, it cannot leave the trapping region. And so that means that this region inside the bubble corresponds to a limit cycle. And outside this region, we have approach to a stable fixed point. So the behavior of the trajectories are really quite beautiful. Some of these will be shown in the visualizations that are upcoming.